Greetings, welcome to Kinematics in 2 dimension. So, in this chapter, we're going to explore the kinematics of a particle moving in 2 dimensions. It means it could move on the in a horizontal and vertical direction at the same time. Okay. So, this is how we represent displacement vector. Okay, it's delta r. Okay, so we represent it this way because we could have um, a displacement vector in terms of x and in terms of y. Sometimes we could also have a three-dimensional vector. So it could move in three-dimensional partition plane. Okay, so we define the average velocity of a particle during the time interval as change in time, as the displacement of the particle divided by the time interval, or V average is equal to the change in the displacement over change in time. Instantaneous velocity is the derivative of the change in displacement with respect to time. Next, we have speed. Now, what is the relationship of speed with velocity? Okay. Speed is the magnitude of the velocity. Okay, or is given this way. Okay, so when you see this on problem, it is asking for the speed or the magnitude of the velocity. As the particle moves from one point to another, its instantaneous velocity vector changes from the initial time to the final velocity at that final time. Knowing the velocity at these points allows us to determine the average acceleration of the particle, or the A average. So A average is given as the change in velocity over change in time, or given this formula. Now, for the instantaneous acceleration, it is the derivative of the velocity with respect to time. Now, our displacement vector can be written this way, wherein x is the x component of that vector and y is the y component of that vector. Okay, I hat and j hat are representation of the axis. I hat represents the x-axis and j hat represents the y-axis. Now, if we're going to analyze if Vf is equal to Vi plus At, and we're talking about a two-dimensional vector, okay, that final velocity can be written this way. Okay, same with this formula. If we know that the formula for the final position is given as initial position plus VIT plus 1/2 AT squared, and we're talking about a two-dimensional vector, therefore it will be written this way. Let's have an example. A particle moves in the xy plane starting from the origin when time is 0 with an initial velocity having an x component of 20 meters per second and the y component is negative 15 meters per second. So 20 and negative 15 are the components of the initial velocity. The particle experiences an acceleration in the positive x direction, given as 4 meters per second squared. Now, we are asked to determine the following. The total velocity vector at any time. So, we're expecting an equation for this one. Letter B, calculate the velocity and speed of the particle at time is equal to 5 seconds and the angle of the velocity vector makes with the positive x-axis. Letter C, determine the x and y coordinates of the particle at any time t and its position vector at this time. So here are the solution. If you're going to analyze it, here is the graphical representation. Okay, so given this formula, Okay, Vf is equal to Vi plus At. This came from the formula acceleration is equal to the change in velocity over change in time. Okay, so since this is a two-dimensional vector, it will be written this way, right? So the x component of that velocity is 20. Okay, x component of the acceleration is 4. Okay, multiplied by time I hat plus the y component of that velocity is negative 15. Okay, it doesn't have a y component for the acceleration, so that means it's 0. So therefore our final answer for the final velocity vector is 20 plus 4t I hat minus 15j hat. Okay, so it is expressed in a unit vector form. Next, letter B, we're asked to calculate the velocity and speed. Okay, so uh, if you're going to simplify this one, we're gonna have 40 I hat minus 15 j hat as our final velocity. 20 plus 20 is 40. Now, to get the direction, okay, that's arctan of the final the y component over the x component of the final velocity. So it gives us negative 21 degrees. It's on the fourth quadrant. Next, to evaluate the speed of the particle as the magnitude of the final velocity, we just simply get the or we simply use the Pythagorean theorem to get the magnitude. Okay, now for letter C, determine the x and y coordinates of the particle at any time t and its position vector at this time. Okay, given this formula, delta x is equal to VIT plus 1 half at squared. So this is for the x component and this is for the y component. Okay? So if you remember, we are given that we have an acceleration on the positive x direction, but we do not have an acceleration vertical on the vertical position. So therefore, acceleration here is 0. That's why we don't have one half AYT squared here anymore. Okay. So for the x component, that's 20t plus 20t squared. And for YF, we have negative 15t. If you're going to combine them, we're going to be having this answer.